Our guest today is the author Andrew Johnson. Andrew is one of our most regular guests and also our friend. Andrew has written many books, and these include 9/11 Finding the Truth, 9/11 Holding the Truth, Climate Change and Global Warming Exposed, and Secrets in the Solar System, Gatekeepers on Earth. Today's show is to discuss the secret space program. Has anti-gravity and free energy devices been invented and then suppressed from us? Let's find out, shall we? And enjoy the show.
Welcome to United Planet. Here we are in the kitchen of Revelation. We're joined by Andrew Johnson, our regular guest now, isn't he? He's been getting Richard D. All, I think, at the amount of invite has been from our programme. Watch this space. Anyway, talking of space.
Good pun.
We'll be discussing his the last book is wrote Finding the Secret Space Program. So it's lovely to have you here today, Andrew. So we're discussing the details of your book and the topics in the book, the secret space program, Find the Secret Space Program, and a lot of it's about anti-gravity, the technology surrounding that, and how it's been hidden. So if you could shoot away and tell us how you got into this. I know you've been interested in space for quite a while, haven't you? And,
yes.
What brought you to this point of writing the book?
Absolutely. Well, thanks for inviting me to come and talk about it. I'm always pleased when people are interested in the topics and stuff. And I know we've done a few of these now, so I hope that people are still interested, as it were, which I think they are.
Yes.
But yeah, so that book, Finding the Secret Space Program, subtitled "Removing Truth's Protective Layers," and I think viewers will perhaps, if they've watched our previous videos, your previous videos with me, they might have a clue as to where that subtitle has come from, because we did do a video, didn't we, about the Apollo missions. It's probably about 3 or 4 months ago we did that now, wasn't it? Something like that. And so this, I put a lot of what I've discussed about the Apollo missions into 4 chapters in this book, and we probably won't cover that again today, because we've covered it, a lot of that. Well, fair
probably use a link to it.
There's a couple of bits and bobs I can probably mention, because to me that's one of the key things. There are other books about the secret space program. There's probably quite a number of them, but there's probably several of them don't openly state that the Apollo missions were a hoax. And that to me is one of the starting points for understanding why there is a secret space program. And that in essence is, as I may have said towards the end of the last interview about Apollo, Apollo was basically, as I see it, one of the aspects of a cover for the secret space program. And getting onto how I came to write that book, as you sort of alluded to, I've always been interested in astronomy. I was probably said when we did the Apollo interview, I watched the missions when I was 4 years old. I had a telescope when I was about 10 years old. It was my brother's, but I used to steal it off him mostly when we had the odd clear night. And I had books about the space program. I remember having a Charles' Astronomy hardback textbook when I was about 10 or 12. Had a picture of Saturn on the front, this sort of thing. And then, as I've probably said on earlier interviews too, I've always had an interest in, UFOs, paranormal. Again, that's partly why we're here and doing this, blah, blah, blah. And it was in 2003 that I sort of started to reinvestigate the UFO issue more, and I got broadband internet again, as I've probably said more than once on these interviews before. And I got into things like the Disclosure Project, and that was where I started to find out a bit more about black programs. And I think I was familiar with that term, as you know, many people are, but you know, I'd heard about things like the SR-71, which was this 1970s advanced jet called the Blackbird. And I think even now the specifications for that, sort of 40 years after it was first flew, are top secret. But it can fly at something like 3 times the speed of sound. And I think when they set this thing going, the fuel leaks out of it initially because of the way the body is designed. And I think because it gets, I can't remember how this would, but I think because the body gets so hot because it's flying at such high speed, the paneling changes shape, and that closes up the leaks. So at low speed, this thing actually leaks a bit of fuel or something, or leaks something anyway. And then when it's going at high speed, that's not a problem because it's presumably the metal's heated up and prevented this problem from occurring. That's what I heard. But you know, you pick up bits and bobs like that. And so I started following those threads from this Disclosure Project. And a little bit before that, as I write about quite a lot in the book, there was Nick Cook's Channel 4 or Channel 5 documentary. I always get confused as to which channel it originally aired on. I think it originally aired on Channel 5 in the UK, and it's called $1 Billion Secret. And I think as it was, that was 2 hours, or 2 separate hours to that program, $1 Billion Secret. And initially back in 1999, I think I only ever saw the first hour. I don't think I managed to catch the second.
Was that based on his book?
What essentially it was the other way around. The book was based on, at least in part, on that documentary. Because he essentially started, I think he made the decision to do the book in the early 90s. And so he'd been doing quite a bit of research, and somebody at Channel 5 approached him, or he approached them and said, you know, let's make a documentary about this subject. And so he was writing the book while doing it, because that documentary came out in 99 and was shown in 99, and the book I think came out, The Hunt for Zero Point, which I refer to many times in my book. That came out in year 2000, I think, or 2001, I forget the exact publication date. So there was a lot of you know, cross fertilization between those two things. And I think because Nick Cook is a former defence journalist, you know, he got a lot of good information together there. He had, you know, he knew how to sort out most of the dross because he was a good journalist, I think. And I think he also realised that there was some stuff that he should have known about, but he didn't know about. In other words, he discovered that certain aspects of black programs were more black than perhaps he'd realised. And as I describe in my book, as he describes in his, because I quote him directly, really, in a number of places. He first got wind of things when he was talking to this guy called, I forget his name, George S. Trimble, I think might be his name. And he had allegedly worked on some type of anti-gravity program in the 1950s in the US, either the US aerospace industry or the US. I think it was Lockheed Martin, or the Martin Aerospace Company, as it was then. And he'd agreed to talk to Nick Cook about this because Nick Cook had started doing the research for this book, or what was to become the book. And a contact at Lockheed Martin, who he names in the book, in his Hunt for Zero Point book, agreed to help him set up an interview with this George Trimble, I think it was, this guy. And then the guy backed out and said, can't do it, you know. And this contact at Lockheed said, I don't know what's got into this guy, but he says, don't ever contact him again, you know. And so Nick Cook was kind of thought, there's got to be something here now. So, you know, he started going after it. So that again was around the same time, 99. Well, that's probably mid 90s that happened. That episode. In the sort of, this was the same sort of time that Dr. Stephen Greer, who put together this Disclosure Project, he was also doing research then into similar things, similar areas, but more with a UFO slant. Nick, you know, in other words, Greer was going in from a UFO slant and getting people from the aerospace industry to talk about that angle, whereas Nick Cook was going in from the aerospace industry and getting them to talk about black programs. So the UFO issue was kind of, he was less interested in that and kind of somewhat less comfortable talking about it because he knew, you know, the sort of ridicule he was going to attract, particularly in him being a mainstream defence journalist. He was actually an editor of Jay's Defence Weekly, either then or soon after then, for a number of years. So that really, I think, is a source that I reference a lot in the book. And you know, I don't make any apologies for that, really. But I wanted to kind of, the objective with doing that was to link up several areas of research, which I don't think, you know, to my way of looking at things, have been properly linked up before. Same as with the Secrets in the Solar System book. I tried to get a number of areas like Face on Mars, put that in one chapter or a couple of chapters. Life on Mars, put that into another chapter. You know, I've done a similar thing here. So I start off with what seems to be the history of anti-gravity research, starting with some pretty conventional stuff. Like, for example, Eric Laithwaite, who was the basically his interest was engineering, and he was based at initially at Manchester University, and then later he went to Imperial College, and he had a sort of side interest. He worked in the aerospace industry. He did some contract work for them in the 1950s, I think, or 1940s, and I understand, although it's not stated overtly in what I read about him, I don't even know if he's written a book, actually. I don't think he ever wrote any books as such, so I've been able to sort of research. Articles, papers, and whatnot, and reports. And he basically worked with gyroscopes because they were used in aircraft navigation systems. So he was putting these navigational assistance units into aircraft, presumably. And he realised that gyroscopes had some unusual properties. Because when you have an object which is spinning at very high speed, it maybe behaves slightly differently than it ought to when you take into account the other laws of physics. And there is a very well-known lecture now by Laithwaite, which was given in 1974 at the Royal Institution as part of the Royal Institution Christmas lectures for young people. And I watched that lecture way back in 1974. I remember watching that lecture. So I was 9 or 10 years old then. And I remember him doing all these wonderful experiments with gyroscopes, and you know, he packed an awful lot in. I think this lecture's 50 minutes. Boy, does he pack a lot of stuff in if you watch the whole thing. He made little things with gyroscopes, where they're on pulleys, they're on little levers, they're on little weighing scales, and you know, he's got a little gyroscope just the size of, you know, sort of that big. And then he has a gyroscope which is like this big and weighs sort of 20 kilograms, you know, and you spin it up, and he says that if you let it go and it bounced, it would go 200 feet in the air. You know, once you spin it up, it has that much energy in it. And he was using these in the lecture theatre with the children and getting them to lift them up. And he does a very simple experiment. He gets a gyro that weighs something like 20 kilograms, and all it is you know, it's a rod with a large disc of metal on it. You pick it up and you're going, oh, can't pick this up. And then what do? You spin it up to 3,000 revs, 4,000 revs, and what can you do? You can lift it up. You can lift it up and you can swing it around your head with relative ease. You know, and there's several videos of him demonstrating this. Not just him, other people have done it as well, because it's a very simple experiment to do.
This is an experiment with a spinning wheel, a rather large wheel, 13 inches diameter, mounted in a ball bearing on a shaft 3 feet long. I am going to hold it like this and swing it in a circle and lift it with one hand, but only when it's spinning. First of all, let me weigh it to show you just how heavy it is. As I talk, you'll see that lifting it is quite an effort. It weighs about 40 pounds, and I can't lift it any higher than that without a lot of strain. So now we'll spin it up to 2,500 revs a minute, at which point it becomes a live thing. Then I shall lift it 5 feet in 3 seconds by going round in a big circle. Whilst I'm doing it, I shall talk to you so that you shall tell from my voice that I'm not under any stress of any kind. Okay. Now in a minute I shall let go with my left hand, and holding this remote end of the shaft only, I shall lift the wheel through 5 feet all on its own with no effort on my part. All I do is apparently just to steer it along a path that it's already decided it would like to go. Then there's the question of how you stop the wheel. At that speed, that wheel has enough energy to throw itself 200 feet in the air.
And I mentioned a couple of repetitions of that experiment in some of the earlier chapters of the book. And that other people have noticed the same as lathe weight, but of course in the physics textbooks, this is all written off as being an effect of angular momentum. So in other words, because you've got this disc spinning and you've got what's called an angular momentum vector, that changes the way that this behaves, because you've got different forces involved because of the inertia contained in the flywheel as it comes in the gyroscope itself. But Lathwaite, having done experiments, and he shows some of these in the Royal Institution lecture, he argues that no, that's not explained. In other words, he basically says, and he makes an extremely good analogy, and he uses a simple circuit. He uses a circuit with a resistor, a voltmeter, and an ammeter, and he puts DC current through this circuit, and the voltmeter reads 12 and the ammeter reads 2 or something. Yeah. And then he runs the same circuit, but he uses AC electricity, and it's all the same components, but the resistance goes down. So you get a higher current, I think it ends up being, and everything else is the same except it's alternating currents in the circuit, but the resistance goes down. So he makes the argument that this is well known in electromagnetics and in the theory of electrical circuits, that the electricity has different effects when it's alternating, and things happen differently when it's alternating and moving in that way, if you can say moving is alternating. And he argues that the same sort of thing is going on with the forces of inertia and gravity and angular momentum in physical science. And so in other words, Newtonian laws, as they're written, don't apply in the same way to gyroscopes as they do to stationary objects. There's something else happening, and that's the argument that he makes. And he stood by that all his life. He said, and they tried to attack him. No, it's not, Eric. No, it's not. They tried to attack him for that and ridicule him.
Conventional science is beyond that.
In other words, he was arguing that something was missing, and that's basically all that he said. He didn't say, I can make an anti-gravity drive. And in this lecture, if you listen to him, he actually says, once I was known for doing this, I had every crackpot in the country contacting me saying they'd built an anti-gravity device. So he wasn't saying he'd invented an anti-gravity device. Neither was he claiming that he'd debunked and people who'd made an anti-gravity device. He didn't say any of that. He was saying, look, these are the experiments, these are the measurements, these are the results, and these are what the results should be. That's all he basically did. And in that regard, he did something very similar to an American physicist who went by the name of Bruce Palma.
Oh yeah.
Who I also have in either the next chapter or the same chapter as Eric Lathwaite. He essentially said pretty much exactly the same as Lathwaite, and he did another simple experiment, which was arguably even simpler than some of Lathwaite's. What Bruce de Palma did was he had a little simple apparatus. It would fire a ball bearing up from a cup into the air through it, and it was in the path of a stroboscope, so you could take photographs with it or have a chart drawn on the wall, and you could measure how fast and how far this ball went. You could measure how much its trajectory changed. Should be a parabolic path in the normal field of gravity. It's called a parabola. It's something you do in physics, you know, as part of your experiments in physics class at school. You know, you throw a projectile, it goes in a parabola. The basis of, you know, ballistics is the parabolic path. And how an army, you know, gun a shell from a tank will, you know, that's how they work out how high to point it, so it'll land on a certain target. But what De Palma discovered with his simple experiments was that if you rotate the ball at like 20,000 RPM and then you fire it up in the air, its path changes.
It's a spinning again.
It doesn't change much, but it changes. The path is not the same. It's not the same parabola as it was when it was still. Now, apparently, he even did this in a vacuum. So anybody that's saying, oh, you know, there's a current of air going around the ball, you know, and that's changing the air pressure, therefore that's changing the air resistance, therefore that's changing. No, he ruled that out. He did these experiments in a vacuum, and he repeated them many times. And it was, again, this notion of spinning. The spinning was causing another effect to happen. And then similarly to Eric Laithwaite, he developed this thing called a force machine. And what he basically did was, I think he suspended this thing from the ceiling, and it was just basically like two big gyroscopes, and he suspended it from like a weighing scales from the ceiling, which had a spring balance. And what did it do when you span it up? It lost 4 kilograms in weight, I think, or 4 pounds, or 4 kilograms. So when it was spinning, what the weighing scale showed was 4 pounds lighter than when it wasn't spinning. So it's the same sort of thing as Laithwaite was talking about. And De Palma made the same sort of argument. And he basically said there is some other type of field, I think he called it, he had a special name for it, like ortho field or something, I forget the name, it's in the book, but I can't bring it to mind now. And this was to do with the inertia of the object. Now, inertia is this property of an object which, you know, which it gains or gathers when it's moving. Because, as you know, when when you stop suddenly in a car, you'll go forward. That's why you have a seatbelt, because you have inertia. You'll continue to move whilst the car is stopped, because you're not essentially not part of the car. But when you get this property of inertia, and with moving objects, this changes things. Again, it changes the overall situation that the object is in. And both Laithwaite and De Palma made the same sort of arguments. Same experiments, really, or very similar, same results. You know. And the basic takeaway from that is that when things are spinning at high speed, you know, say above 2,000, 3,000 RPM, other things are going on which you need to take into account.
That changes the weight of that object, so it's of course the gravity field.
And I mean, normally you wouldn't bother to measure it in most environments. Or you've got an engine in a factory or something running at 10,000. Why are you going to weigh that engine? You know, why would you weigh an aeroplane engine when it's stationary and when it's running? You're not going to do that normally. So they discovered this effect because they actually observed it and did experiments on it. So that's really a starting point for some of the research. So what's causing this effect? Why is this spinning changing the weight? Now, I don't give an answer in the book really as to why I think that's. I don't really know, but I suspect what it's to do with is the interaction between atoms. So the atoms or the molecules interact differently, and I think it's to do with the transfers of electrons somehow within the material. That is influenced when it starts to spin at a certain speed. And I think if you read the rest of the book, you'll perhaps see where those sorts of ideas come into play, because one of the other chapters which I've got is about the work of Thomas Townsend Brown with electrogravitics. And again,
with the string theory that comes in.
The string theory with that I cover. In other words, I sort of skipped over that, but the string theory, I cover that in the first couple of chapters
Yeah.
as a way of saying, yeah, okay, I acknowledge what mainstream physics says, and string theory is meant to be a possible explanation as to why gravity behaves the way it does, and they say gravity is transmitted by a certain type of string, or the absence of a string, or a string breaking off and going into another dimension, so you're left with this net force, which is much smaller than it should be, which is why the gravitational force, I think, is, I don't know, 300 billion times weaker, whatever the figure is. I forget, the figures are again in the book, but it's billions of times weaker, or trillions of times weaker than the electromagnetic force, which is a bit of a mystery to physicists. And the common demonstration of that is that, you know, you have a bunch of keys or an object. Yeah, a bunch of keys is what the example is. Put that on the floor and it sticks to the floor. You've got the whole of the mass of the Earth attracting that bunch of keys to make it stick on the floor, on the ground. Yet you can pick up that bunch of keys with a normal bar magnet, you know, that you can get in a toy shop, and that defeats the force of gravity pulling down on it. And that's just a little magnet you can hold in your hand. So that's an illustration of how much stronger the magnetic force is than the gravitational force. So that again, they tried to explain that in string theory, but to me, string theory, quantum mechanics, pretty much a dead end, really, because they don't really explain the effects I've just talked about. They don't even, you know, for example, they don't even talk about experiments with high-speed spinning gyroscopes. None of the physicists that talk about string theory will talk about, oh yeah, this explains the anomalous apparent weight change of spinning gyroscopes. That's not addressed. That's just addressed by normal standard Newtonian physics. But if it, or they at least say they claim it is, you know. So string theory doesn't cut it. There's another one called loop quantum gravity, which I'll mention about half a page on that. Some people sort of look at that. But these are theories, you know, these are theories.
Yeah, that's it,
And Brian Greene, who's sort of did a whole documentary on string theory back in 2003, which I watched, he writes on Britannica.com that string theory is a fantastic theory, but it's basically highly mathematical. There's only about 20 people in the world understand it, and none of the conclusions are supported by observation. You know, and that he actually overtly says that. You know, you might remember. I thought, yeah, good on you, Brian. You, at least you're saying the honest thing. You know,
that's true. Yeah.
So you think, and then you think, well, just taking a brief sidestep into 9/11 that we've discussed at length before. I always go back to that. Somebody knows about gravity because of the effects we saw on 9/11.
This is all the connection again, isn't it?
Yeah. And again, you won't find other secret space program books mentioning 9/11, or at least not with any sort of realization of what the actual evidence and the truth shows. So that was another objective in this book, was to bring that in, stick it in, show where it fitted, etc. Maybe we'll get to that in a bit. So you've got Bruce De Palma doing research, Eric Laithwaite. There's another guy who became quite well known for his lectures that published on YouTube, and again his name escapes me, Walter Lewin or Levin, I don't know if it's spelt Lewin, but it might be pronounced Levin because it might be German, I'm not sure. I think it's Lewin. And he's got some great lectures, some great physics lectures which you can watch on YouTube. He's one of these guys who's just a really good lecturer, you know. He's just interesting. The moment you start watching his lecture, you know he's going to be interesting because of the way he delivers it, his phraseology. You know, he's got a flair to him, a charisma. You know you're going to enjoy it. And he did some good demonstrations. These lectures were videoed, I think, back in the 90s, and then he put them on YouTube, I think, at some point. And he's also got another good lecture, or demonstration, which I didn't put in the book, but it's tangentially relevant. And it was an experiment done by Kelvin, Lord Kelvin, the physicist, I think in the early 1900s or late 1800s. And it's a very simple experiment. You get 2 tanks of water side by side, and then you cross-connect them with a conducting rod, and then you let water drip out of them, and then you have 2 little balls next to each other about 1 inch apart, and you just let these tanks drip for a period of time, and then after about 10 seconds you'll get a spark between these 2 metal balls.
And let's first look at the sparks. So I will start the water running now. Let's just be patient a little bit. And let's see where we see in spark. Did you see one? Did you see the spark? Well, you were not looking. Man, you're paying for this. Look at the two balls. Give it some time again. Have to charge up. I can already anticipate it's coming up. It's coming up. Yeah! Did you see it? 10, 15,000 volts. Let's give it a little bit more time and then we'll take a look at the water flow, which I can see. I'm close. But we can make you see the water flow. Look again. It's coming up. Did you see it? I could see it coming up. I can make you listen by having my microphone near the water, and you can hear this water running. Familiar sound to all of us. And now the sound changes. You hear change? And there's a spark. Once more. Just running. Spreading. Coming up. Yeah! Amazing, isn't it? I can make you see this water. Just stay there. We have 1.5 minutes left. So now you can see the water. You happy with the light, Marcos? You can improve on it. So look at the water. It was just spreading already. You can't see the spark and the water at the same time. So the water is running now normally. It's going to spread slowly. I will tell you when I see the spark here, but it's already, I can almost predict when it happens. The water is spreading now. Coming up shortly. Yeah, I saw the spark. And you immediately see the water go like this.
And he also does a very good demonstration where he goes behind the scenes at this lecture theatre, brings out a briefcase, having, talked to somebody behind the screen for a minute, gives it to this guy, and the guy, he says, right, make some turns. And as he's turning, the case tilts upwards, because inside this case, he's got a gyroscope spinning at high speed. So again, you get this apparent anti-gravity effect on the case, because the case is free to move. And you can see him do this as a demonstration. It's a fun little demonstration. But again, it's really just demonstrating what Eric Laithwaite did, but with it in a slightly different dressing, So that's a very interesting. I do mention that in the book, and I'd lifted a couple of stills for that, just to get people thinking there's something else going on here. That there is something going on here, and we know there's stuff going on because of all the videos we've already done. So that's where I go in the associated book. Thomas Townsend Brown, I think, comes next, and he was working from the 1920s because again he discovered another sort of weight change effect, but not with spinning gyroscopes, but with electrical equipment. And I think he was doing work with early X-ray tubes, where with X-ray tubes, as some people may know, you have to charge them up to a high voltage to make them work. Something like 25,000 volts or 25 kilovolts. Anything above that, if you have a tube, charge it up to that, then you get X-rays, and that's how they make an X-ray tube, which then is used to, for medical reasons, medical applications, I should say. I remember my brother telling me about this, that some people were concerned that even in the old style cathode ray tube TV sets, the ones we all had up until about 10, 15 years ago, some people thought you could get X-rays from those because you've got high voltage. But I think the voltage in those only goes up to about 15 or 20 kilovolts inside those tubes. So you're less likely to get X-rays from that. But I remember my brother worked with somebody who was pregnant, and they wanted a lead apron to protect themselves from the X-rays because they were at a VDU all day long, and they were worried. So they got them a lead apron, didn't really argue with them because it was the cheapest enough thing to get from, if that gives you worker security. Anyway, I'm digressing. But so electrogravitics, this is what Townsend Brown, he was working these X-ray tubes, and he noticed when they power them up and put like whatever 25, 30 kilovolts through them, they'd sort of lurch. There was this like lurching effect, and they'd wobble in the holders. I was like, what's causing that? Why would that lurch? Why would that physically move from an electrical charge? So I thought that was a bit odd. And then he started to do some experiments, and eventually he was able to prove that if you charged objects up, they would lose weight. And he repeated these experiments many times. He developed versions of this that would work in a fluid. Eventually called them gravitator discs, and he had a patent for them, and he was able to get things to spin, anomalously when he charged them up on one side, and I think he did some experiments in a vacuum, at least later on, to show that this wasn't just what they call an ion wind effect, because some people will claim that it's a bit like if you've ever put your hand near a high static charge, like for example, you may have even felt this going back to the old TV screens, and if you ever switch one off and you put your hand next to it, you've got this furry feeling, and occasionally you get a spark as well. So that's like the air is affected by the charge. Some people argue that this electrogravitic effect is just ions of air, ionized air, and the air molecules are moving more quickly. That creates thrust, and that's all it is. Townsend Brown was very careful over many years to rule this out.
In a vacuum.
And he did some experiments in a vacuum, and I think he was able to get weight losses of up to about 250 grams, I think, something like that, with some of his experiments. And it wasn't a huge thing that he did in terms of weight loss, but he did enough experiments to show something real was going on, and the effects became more pronounced the higher the voltage. So he was working at initially sort of 50 kilovolts, and he went up from there. I think he got up to about 2 million volts with some of his equipment, and he was really starting to get some more severe effects. But there are claims then that, of course, because he was working. He ended up working at the, I think the US Naval Laboratory as one of the places he worked. And he was doing experiments there because they, I think, were interested for various reasons in his research. So people argue that some of his research went into the black.
Oh, yeah.
And I quote a couple of letters that he wrote in the 1980s where people have, been writing to him. I think he died in about 86, 87, something like that. And people were writing to him saying, "Oh, where can I find out more about your experiments? How can I reproduce them?" And he wrote back to one person and said, "I'm sorry, but my research has been, given to a Californian company, and it's now secret." And I can't publish the results. Won't be published until their work is, complete. So can't tell you anything. Sorry, mate.
Exactly.
So he openly implied in letters that secrecy was involved. And although that in of itself is not massively, significant, it's another of these little pegs on the way, which is thinking, okay. And then Paul Laviolette wrote his book Secrets of Anti-Gravity. That's also a very good book that I refer to quite a number of times in my book. He's got a lot of technical information in there, physics, he's got calculus in there and all kinds of stuff, which is not in my book. So his book, it can be read by non-technical readers, but it's got a lot more technical information in it than mine has. He basically found a document in 1985 about the US Air Force doing work in electrogravitics, because he couldn't find any record of them actually doing this. And then eventually, after I think several months or years of searching, he found a reference to one particular document. There was only one copy, and this was in the library apparently at, I believe, Wright-Patterson Air Force Base. Where have we heard that before? People that are not familiar with that, that's where they say they took the bodies from Roswell, from the Roswell crash to Wright-Patterson Air Force Base. And that air base also came up in a documentary I watched fairly recently, which was a debunking documentary about UFOs from CBS. I think it's from about 1965, and it's very interesting. Although it's a debunking documentary, there's some interesting clips in there about the military bragging about what they can track and how well they can track things. And this is like mid-60s, late 60s. You want to watch that documentary. They're bragging that they can track objects like 3 inches in size or something like that. Back in the 60s. And then where do they show a clip of? Wright-Patterson Air Force Base, and I think it's there that they show the Foreign Technology Division, which I also mentioned later on in my book. So so you're already getting something. You're getting aerospace, Brown, anti-gravity research. You're getting Air Forces involved. Naval Research Laboratory seems to be involved. So you've got that.
Hello!
And thank you very much for watching the video. Really hope you enjoyed it. If you did, and I hope you did, please give it a little like. And of course, subscribe to our channel.
We also have our Facebook account, information is below, and ways you can fund us is also down below. And remember, let's unite and not to fight.
And together, we can unite this planet better. Thank you very much.
Bye bye.
Bye bye.